We'll wait for 5 minutes and then we'll start the session.
आपका इंजन का मतलब ठीक ठाक है क्यों क्या हो कितने दिन में डायरेक्टर को लेफ्ट का सामने है मुझे कवर करना है क्या तो लेफ्ट हमने हमारा जो ब्रेन है उसको कवर करना ठीक डायरेक्टर को नहीं मतलब हम यदि इसका एक्शन नहीं लेंगे तो डायरेक्टर अच्छा होगा सर ये एक नया ईमेल आया है मुझे आपको भी चार ग्रुप में है ना। हाँ तो आप देखिए आपका मेल में आया है। फिर हम हम तो ये देखिए 2 पेज का पूरा लिस्ट दिया क्या क्या करना क्या क्या नहीं। ये लिखो लिखता नहीं रेस्ट नहीं लिखा होगा। मैंने तो इतना देखा अब छोड़ दो। हाँ वो ट्रेन का कवर कैसे करेंगे वो।
So, a meeting started. Uh, Welcome everyone to the live interactive session number 3 for the course Mechanics of Fiber Reinforced Polymer Composite Structure. Today we are going to solve some sample problems which will be useful for solving assignment number 3. And I am Aninda Mandal. I am one of the TA of this course. So as the new module number 3 started with the macro mechanics of lamina. And when we started with the macro mechanics, the first assumption that was taken. So as we started with the third module about the macro mechanics of lamina, so one of the first assumption that was taken that a typical lamina is very thin compared to its in-plane dimensions, and in absence of out-of-plane load, it is assumed to be in plane state of stress. That means that we are considering any lamina as orthotropic, but the thickness of that lamina is very less. So we are considering any lamina and its properties to be orthotropic, but one of the thickness of that lamina will be very less, such that in the direction number 3, as you can see in this diagram, so in this direction the thickness is so less that the properties won't change that much. So all the property change will be considering that the lamina is in the plane of direction 1 2. So the direction of the plane is 1 2, which is normal to direction 3, and the properties in the direction 3 will not change that much. So considering this assumption, we can say that sigma 1 2 and tau 1 2 will be non-zero, whereas sigma 3, tau 2 3 and tau 1 3 will be equal to 0. So by using these assumptions, the initial compliance matrix that we had, we can further reduce it so that we will have only 4 independent constants that we have to solve our equations with. So this is the reduced stiffness matrix, as you can see. So this initially it was known as the stiffness matrix, which considers like 6 variables in the right side and 6 in the left side. Then we further reduced it, considering that the thickness is so less that in that direction there is no property change. So now this is known as the reduced stiffness matrix, where we are only considering sigma 1 2, tau 1 2, and similarly epsilon 1, epsilon 2, and gamma 1 2. So these are the equations which from the values of the coefficients in the stiffness matrix, we can find the values of the reduced stiffness matrix coefficients, and how these reduced stiffness matrix coefficients are related to the engineering constants. So these are taught. So now let's discuss some sample questions for the assignment number 3. So the first question is, a unidirectional lamina is. So this question we have already tackled in previous assignment or previous live sessions, but now that we are starting first with a lamina, so the first question came considering the definition of a lamina. So a unidirectional lamina is, so answer will be a heterogeneous and anisotropic. Anisotropic, as you can see, a lamina is nothing but a single layer of fiber, that is the reinforcement, and a matrix combining that combining with that reinforcement. So a single layer which has only on one layer of reinforcement and a matrix around it, that forms one single lamina. And this lamina will be heterogeneous and anisotropic. So heterogeneous is the properties are location dependent. Any point in this whole lamina, if you uh, if you point at any point, it can have either the reinforcement part or the matrix part. So it is not uniform. The properties won't be uniform. That's why we are calling it heterogeneous. Okay, so heterogeneous because any point on that lamina, it can have the properties. If you put pinpoint on a lamina, the properties are distinguished because of the matrix and the reinforcement part. So it is not homogeneously distributed, as the properties in any point in any location on that lamina will be different depending on at that location what is the significant part, either only matrix or reinforcement. That's why it is heterogeneous. Whereas anisotropic, because the properties are direction dependent. That means the layers of reinforcement, how they are aligned, accordingly the properties in all the other directions will depend on the alignment of the reinforcement. As you can see here, these reinforcements are aligned like this in direction 1. So when you will put a stress in direction 2, the value will be different. When you will put a stress in direction 1, the values will be different, or in direction 3, the values will be different. So according to the direction, the properties will change. That's why lamina is known as anisotropic. So this will be the answer. The second question is, anisotropic materials are those materials where the properties at a point are. So already discussed, anisotropic are defined by that the properties are direction dependent. So the answer here will be, it is dependent on the direction in anisotropic material. Now question number 3 is that in especially orthotropic lamina. So options are A, principal material axis directions do not coincide with the analysis axis. Option B, principal material axis direction coincide with the analysis axis. Option C, principal material axis directions may or may not coincide with the analysis axis. Or D, special type of fibers are used. So already sir taught in the class that there are two types of orthotropic lamina, specially orthotropic lamina or generally orthotropic lamina. So specially orthotropic lamina says that the analysis axis, that is XYZ, coincide with the material axis 1, 2, 3. Whereas generally orthotropic lamina, those in its analysis axis XYZ do not coincide with the material axis 1, 2, 3. So now what is the analysis axis and what is material axis? So analysis axis is, suppose we have a lamina and the universal principal axis that we use, that is x, y, z. So we will consider the x, y and z direction for certain lamina. But the lamina's properties changes depending on the alignment of the reinforcement. So the reinforcement fibers, how they are aligned, accordingly the properties will be different. If they are aligned in like parallel to the axis x, so that property will be different. Parallel to y, that will be different. But still x and y can be replaceable if it's a single lamina. So if it's a single lamina and either it is in 90 degree or 0 degree, you can decide from yourself which one you can consider x, y, z. But if it is more than one layer of lamina and forms a laminate, then you have to consider x, y, z as your particular axis, and accordingly you will get material axis to all these laminas. So now what is material axis? So it is when the reinforcement is aligned in different angles. So at that time, the force at the alignment of that reinforcement in the direction we consider it as the material axis. As the the stress withholding capacity of that lamina, that reinforcement will be highest in the direction of its application, such that we are saying the reinforcement is at 45 degree. So in the 45 degree angle, the stress beared by that lamina will be highest. So we consider that as the material axis 1, and accordingly 90 degree to that we give axis number 2 and axis number 3. So when initially we are considering a lamina, it can be 0 or 90, that we can't decide, and we can give it can be general, it can be a specific, especially orthotropic lamina, because the both xyz and 1, 2, 3 can coincide with each other. But if we are talking about an angled one in which the reinforcements are in angle, or when we further start talking about laminates where we will have more than one lamina, so they will have different angles with respect to each other. At that time, we will consider them as generally orthotropic laminas, and their particular axis will not coincide with the material axis. So in this question, they are talking about a specially orthotropic lamina. So from the definition, it is one whose analysis axis will coincide with material axis. So option B is the correct answer. Now next question is that in a UD glass epoxy lamina, that is unidirectional glass epoxy lamina, is loaded in a UTM along direction 1. So in direction 1, it is getting stress. So and the corresponding to increasing stress values, the strains along 1 and 2 are recorded using two strain gauges mounted. And the following readings are obtained. Obtained. So 1 and 2 represent the principal material directions. So stress in the direction the stress is in the direction 1, so values are given in megapascal, and the strain values are using strain gauge they have calculated in the UTM, so that values are given strain sigma 1 and epsilon 1 and epsilon 2 values. Now they have asked, question number 4 is that the longitudinal Young's modulus is. Now Young's modulus, a longitudinal Young's modulus. So longitudinal here, as the force is in direction 1, so we will consider that as the longitudinal force, and in direction 2 it will be transverse force. So all these terms should be clear whenever you are solving the question. What those terms mean? So longitudinal here means that as the load is applied in direction 1, so that will be the longitudinal direction, and 90 degree to that in direction 2 will be the transverse direction for this particular case. Now they are talking about Young's modulus. So what is Young's modulus? So you can see the stress strain diagram. It's a general diagram. So how a material undergoes deformation is such that initially there will be a linear line between the stress and strain until it reaches the yield strength. After that, further increasing in stress, it will go to the ultimate strength and later it will fracture. So from this stress strain curve, you can find the Young's modulus, which will be the slope. So this slope will give you the Young's modulus of that material. So in this case, we have to find the Young's modulus in the longitudinal direction. Longitudinal means we have to consider the stress in direction 1 and strain in direction 1 also. So we here you can draw a graph between the stress and strain in one direction. So this is a graph I have created in Excel from all the data given. Now we have to find the slope of this. Curve. So slope, as we all know, the equation of slope is y2 minus y1 by x2 minus x1. So from that, putting the values of y2, y1, x2, x1, and we have to always consider the units, and accordingly we can find the value in gigapascal as 40. So this is the Young's modulus, longitudinal Young's modulus as 40 gigapascal. Now next question, with the same data, they have asked about the major Poisson's ratio. Now there are two types of Poisson ratio, major and minor. So major Poisson ratio equation is mu12, which is equal to minus epsilon 2 by epsilon 1. That is the when there is a load in direction 1, then it will be called as the major Poisson ratio, and when there is a load in the transverse direction, that will form the minor Poisson ratio. And this major and minor, in between these two, the major Poisson ratio will always have a higher value. So accordingly, here the equations are already know of major and minor Poisson ratio. So they have asked about major Poisson ratio, which is mu12, that will be equal to minus epsilon 2 by epsilon 1. So either you can like this, you can form the graph of the strain 1 and strain 2 from that the epsilon 1 and epsilon 2, and you can get the slope of it, or you can, if it is a linear graph like you can see here, Then you can take the ratio of any two of the values, like here I took the value of minus 18.75 divided by 75. That will also give the value 0.25. Or you can take the slope of this curve. If it is a linear curve, you can take the slope also and it will give you the same value. The next question is for the same data, that if the lamina is now subjected to biaxial normal stress, that is sigma 1 and sigma 2 equal to 2 megapascal, then the longitudinal strain is epsilon 1. We have to find the value of epsilon 1. Now for this question, as there are two different stresses are given, and there will be more relation of strains depending on the engineering constants. So we have to go back to our compliance matrix. So here you can see the compliance matrix for an orthotropic material. So this is a compliance matrix for an orthotropic material. So we have given the value of sigma 1 and sigma 2. So these two values are given 2 megapascal, and considering that all these values are 0. So for that we have to find epsilon 1, the value of this. So with the help of this compliance matrix, you can find the equation for epsilon 1. That will be epsilon 1 equal to 1 by modulus 1 into sigma 1 minus Poisson ratio mu2 1 by E2 into sigma 2, and this value will be multiplied by 0. So that would all the other terms will become 0. So this will be the final equation for epsilon 1, that is sigma 1 by E1 minus mu1 2 sigma 2 by E1. Now this E1 value, which is the longitudinal modulus and the major Poisson ratio, we have already solved in the previous two questions. So from these two values, when you put these values here, sigma 1 and sigma 2 is also known, that is 2 megapascal. Now take care of the units, and finally, with respect to what unit they have asked, you can solve, and this will be the answer. So any doubts till now? Yes, Sachin?
Am I audible, ma'am?
Yes, you are audible.
Ma'am, please go to question number 5.
Yes.
Okay. Um, uh, Question number 5, ma'am.
This is question number 5.
This is question number 6. This, yes, ma'am.
This one?
Uh, no, question number 4. Question number 4. Yeah, ma'am, here this MPA value is taken 4 minus 3 into 10 raised to 6, and here 100 minus 75 into 10 raised to minus 6. So could you elaborate how this 10 raised to 6 and 10 raised to minus 6 has came? Like, if when you are converting this MPA to GPA, generally it will be 10 raised to 3, and micrometer per meter, if you consider. So just I'm a little bit confused, could you elaborate it?
Okay, so Pascal to gigapascal. Okay, so only we have to consider there is a megapascal. That's why I took it in the form of Pascal. So that will be 10 to the power 6 Pascal. Now 10 to the power minus 6, because this micron meter I am converted into meter. So it will be meter by meter, that will get cancelled. So only so to convert micrometer by meter, I have multiplied here 10 to the power minus 6, and here in terms of Pascal I am
Hmm.
writing 10 to the power 6, and later that Pascal we will convert to gigapascal, that is 10, that will be 10 to the power 6. That's it. Okay, so you're saying that this should be 3,
Uh,
right? Okay, okay. I think when you will solve this, like here we wrote in terms of Pascal, this will cancel 4 minus 3 will be 1 by 25. So 1 by 25 into 10 to the power 3, you will get in terms of gigapascal. That's why gigapascal is 10 to the power 9.
10
So
raised to power
1,
9. How 10 raised to power 9, ma'am? Because these values are 4 minus 3. They are in MPa, right?
yes,
So when we are converting that MPa into GPa, we should multiply with the into 10 raised to 3, right? If
yes,
I'm not wrong.
yes, yes,
Yeah,
yes, you're right.
and yeah, and then this take up strain. So generally, strain is a dimensionless, but when we'll take it strain, this micrometer per meter. Uh,
Yes, that's why they are
That
multiplied by 10
10
to
to
the
the,
power minus 6.
yeah, that
uh,
micron is converted into meter. That's why it is multiplied by 10 to the power minus 6 in the denominator.
okay, then this 10 raised to 6, is it correct? Like
That
this.
will, what will be the value here? It will be 1 by 25. 1 by 25, 1 by 25, 10 to the power 6 plus 6. That will be 10 to the power 12. So gigapascal you need in 10 to the power 9. So if you convert 1 by 25, so it will be 1 by 25 into 10 to the power 12. When you will convert into form of 10 to the power 9, it will come as 40, I think.
Okay.
Let me check. 1 by, yes, that will be correct. Because it, what will be the value here? It is 1, that will be 25. This whole 10 to the power 6 minus minus 6, that will be 10 to the power 12. So it will be 1 by 25
10,
into 10 to the power 12. So 1 by 25 is 0.04. So 0.04 into 10 to the power 3 will be 40. So that will become 40 gigapascal.
okay. Okay. And ma'am, question number 6.
This one.
Huh. Here, this epsilon is equal to sigma 1 upon E1. If you see here in this matrix, if we take epsilon 1 is equal to, if you multiply with the sigma 1, it should be 1 upon E1. So sigma 1 upon E1 minus mu 1 2 upon uh, E2 into sigma 2. Am I right? Or this E1 and E2, I think it should be E2, right? Sigma 2 upon E2 or E1.
Yeah.
It has to E1. It has to E2. I'm not getting it. Sigma 2 upon E2.
Um, Wait, I think there is some problem in this compliance matrix maybe.
So it has to E2, but I think it should be E2.
Yes, it should be sigma 2 upon E2, not E1.
Yeah.
Yeah, yeah.
Mm.
So then in that case, how to calculate E2 then?
Yeah, we don't. Okay, we have already calculated for E1. We don't have
E1, yeah.
sigma 2,
Yeah.
New,
right?
Yeah.
new, new 2, new 1 2 upon E1 is equal to
But
new 2
uh,
1 upon E2, like that. We can calculate from that
okay,
formula.
okay. The equation, this equation is the incorrect one. E1, it will be E2. But then sigma 1 and sigma 2 both are similar. That's why I'm considering that E1 will be equal to E2. That's why only in this equation there is the correction will be that this
So
will
it
be
has
E2.
to.
Okay.
So sigma 2 upon E2 has to be there, no, right?
Yes, sigma 2 by E2 will be there. But as you can see,
Yeah.
sigma 1 and sigma 2 is similar. That's why we are considering that E1 and E2 will also be equal.
Sigma 2 and sigma 1 are okay, 2 MPa. Okay. Because in the tutorial, I think it has not given sigma 1 and sigma 2 both are not same in assignment.
Okay.
Yeah. That's why we have to calculate E2. In that, but sir said, as sir said, we can calculate by using mu1 2 and E2 that relation.
Yeah, there is an equation between major and minor Poisson ratio and E1, E2 also.
Yeah,
So from
yeah,
that
yeah,
we
yeah,
can
yeah,
calculate. Yeah,
yeah, yeah, yeah. Okay, thank you, ma'am.
yeah. Okay. Thank you. Actually, I didn't even notice this mistake I did. I'm so sorry.
No, 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 no,
I
no,
will try
no,
to
no,
attend.
ma'am. I thought it will be, matlab, I'm uh, considering wrong. That's why I ask you.
But I think, yeah, I didn't even notice this one. Thank you so much for pointing. Okay. Um,
But ma'am,
yes. Huh?
if sigma 1 is not equal to sigma 2, then how will we calculate it E2?
That's what we just said. Na? There is an equation between E1, E2, mu1, 2 and mu2, 1. So mu1 to mu2, 1 we can find the major and minor Poisson ratio from the data. And also E1 is already known. So from that we can find the value of E2. Remember in last class also there was an equation between Poisson ratios and E1, E2. So we can use that.
Okay, ma'am.
I can try to find that equation. This equation was there. Remember the relation between E1, E2, mu2, 1 and mu1, 2. So we know mu values and E1 value, from that E2 can be found. So if they are different, but in this case sigma was same, that's why we can consider E1 equal to E2. Okay, should I continue?
Yes, yes, ma'am.
Uh, Okay, so the next question is the question number 7, that engineering constants in the principal material directions for a typical glass epoxy lamina are given: E1 equal to 40 gigapascal, E2 equal to 10 gigapascal, mu12 equal to 0.25, and G12 is equal to 5 gigapascal. If the lamina is subjected to a uniaxial tensile stress of sigma 1 equal to 2 megapascal along the longitudinal direction 1, the strains in mu m by m induced are. So here we have already given the engineering constants in the principal material direction. So for and we know the relation between the coefficients of the compliance matrix and the engineering constant. So first we will do what we will do. We will we will write our uh, reduced compliance matrix, as this is the reduced compliance matrix. So here it is given only sigma 1 is value is known, that is 2 megapascal, and all the other values we are considering as 0. So from that we can get the relation between the epsilon 1, epsilon 2 and gamma 1 2. So epsilon 1 will be equal to S11 sigma 1, epsilon 2 will be S12 sigma 1, and gamma 12 will equal to 0. Now, by the definition of modulus, that is E1 is the modulus, will be stress by strain. So, stress in direction 1 divided by strain in direction 1. By this equation, if you can see, if you from this relation, you can find the value of S11, that will be E1 equal to 1 by S11. So, one of the values of this coefficient in the reduced compliance matrix we got, and the second one we need is S12. So we have the definition of Poisson ratio. Mu12 is equal to minus epsilon 2 by epsilon 1. So epsilon 2 by epsilon 1, if we do, it will be equal to minus S12 by S11. S11 value already know from the modulus, and we can find the value of S12. So now we have the value of S11, S12. From that we can find the values of the epsilon 1 and epsilon 2, and gamma 12 is already 0. So that's what asked in the question. Then what is the strain induced in direction 1 and 2, and the shear strain in direction 1, 2. So from putting those values of S11 and S12 in the equation, in these two equations, you can easily find the value of epsilon 1 and epsilon 2. So this will be the answer, option A. Epsilon 1 will be 50, epsilon 2 will be minus 12.5, and gamma 1, 2 will be equal to 0.
Ma'am, here is the compliance matrix. I didn't get this. How this compliance matrix is coming?
This is the reduced compliance matrix.
Yeah, yeah, it's
So,
no. But here, yes, compliance matrix. Right, there's two AC, my 11 like that. How this coming?
Sir has already discussed it in his lecture. Like I took this photo from the lecture only. How to reduce it from the normal matrix to this one. Uh, I think in the first slide. So this is the okay. Sorry. Uh, this is the matrix I took. So considering that sigma 1, sigma 2 and tau 1, 2 is non-zero and sigma 3, tau 2, 3 and tau 1, 3 are 0. So from the initial compliance matrix, we reduced it to this one. Okay.
Okay.
Yeah. So this all based on this assumption. So when we started macromechanics, we came with this assumption. So simplify our like calculation. That's how from the by considering these 3 points as 0, we minimize their initial compliance matrix to this one, which only has like four unknown independent four independent variables. That will be S11, S12, which will be equal to S21, S22, and S66. So this is the new which will be forward when we will go, we will be using in this form only. Did you, were you convinced or do you have any doubts? You can ask. Okay, then I will continue. So this one is clear. So we will use this reduced compliance matrix and we all these two for values are 0. We have given the value of sigma 1. From that we can find the epsilon 1 and epsilon 2 and gamma 1, 2 values from this. The next question is that for the same given data, the global strains induced in a 45-degree glass epoxy lamina when only sigma x is equal to 1 megapascal is applied with sigma y and tau xy equal to 0. Now when yes, it is given at an angle, then initially we use the reduced compliance matrix. Now we have to transform it for an angled lamina. So the transformation equations are already taught in the class. So these are the equations which are through which you can convert the reduced compliance matrix to transformed reduced compliance matrix. Okay, so transformed means whenever we are dealing with any angle, then we have to convert this reduced matrix in the form of that angle. That is done by the transformation matrix, that is in terms of the cosine, angles and all. So from that transformative matrix when multiplied with the compliance matrix, reduced compliance matrix, by these equations, we will get this new matrix which is a transformed reduced compliance matrix. So whenever we have to deal with any angle, we have to use these equations to convert this to this. So now this reduced compliance matrix we already had from the previous question. Now we have to convert it for a 45-degree angle. So these are the equations we have to follow. These are like big equations, but from this we can get the different coefficients of this transformed reduced compliance matrix. So this is the new matrix. Now we have to apply what are the conditions given in the question. So in the question, they are given the condition that only sigma x is given equal to 1 megapascal and everything, all the other stresses are equal to 0. So again, we will put it as strain equal to the matrix into stress. So stress value is given, that is 1, others are 0. For this, and we will use this matrix. From that, we can get the global strains induced in that 45-degree angle. That will be the answer, option number A. The epsilon x is equal to 78.125, epsilon y equal to minus 21.875, and gamma x equal to minus 37.5. So this will be a very lengthy question. So from the previous question, we already got the values of S11, S12, S22 from the engineering constants that are given in the question. After getting this reduced compliance matrix, we have to use these equations to transform it for the given angle, and that will be the transformed reduced compliance matrix. And then we have to put the conditions that are given in the question for the stress and strain. And like if we are given the values of stress, we can find the values of strain by using the compliance matrix, or if we are given the values of strain and we have to find the stress, then we will use the transformed reduced stiffness matrix. Okay. So next question for the same data is that the global strains induced in a 45-degree glass epoxy lamina when only sigma y equal to 1 megapascal is applied with sigma x and tau xy equal to 0. So we will use this new found transformed compliance matrix, reduced compliance matrix for this case also. So in case, so we have solved till here. Later for the next question, in this part, as initially sigma x we took as 1, here we will take in this question sigma y is equal to 1 and solve for the epsilon, the global strains. And the next question is the global strains induced in a 45-degree glass epoxy lamina when only tau xy equal to 1 megapascal is applied. So it's the same one, similar to as already we have got this matrix. We will use this again here by changing the stress. That will be a shear stress we are applying here, 1 megapascal. So putting that value with this matrix, we can get the value of the strains. So for solving these kind of questions, you have to remember these equations. These are very important for finding this transformed reduced matrix. And then according to what stress or strain they are given, you can solve by using this method. So any doubts in that? So it was all clear. Do you have any doubts in any of the questions?
Hello, ma'am.
So, yes, Vijayda.
Uh, this one solved, na? Solved PDF. Could you share that in this link?
Solve PDF means you want this PPT.
Yes, ma'am. You just now you solved, na, ma'am? That's one PDF. Could you share that one PDF in link?
No, I didn't solve anything. This everything is in this PPT. PPT will be already solved. Like you would have been given the link of the drive in which you can get all the PPT which I prepare.
Okay, okay, ma'am. Okay.
Yeah, it will be. It is already shared by NPTEL, I think. The whole drive in which you will get the link of the YouTube video of this recording and also the PPTs that I make. I put it there. Okay.
Okay, ma'am. Okay, no problem. I will check.
Okay. Yes, Sachin, you were raising your hand.
Yeah, ma'am. Just I would like to, could you go back to problems?
Which one?
Uh, the prob One minute, ma'am. Okay, second. Question number 8. Okay, fine. Ma'am, this, for example, take this reduced stiffness S bar, S1. For example, take stiffness S11 bar, and its value is coming out to be 0.78125. So now it has taken like the so we have to put all those values, cos and all, and then it will come like, is it like that?
Yes, yes. So this is the equation. If I can
So
zoom in.
if I
So these are the
put all,
equations.
yeah. So if I
Huh.
put all values for example cos, cos this theta raised to 4,
Hmm.
and then
Hmm.
S11 value and like S6 and like
Yeah, yeah. You will
then
need
I will
all
get
these values.
S1. Yeah, and when I'll
Yes,
solve
yes,
it,
yes,
then I will get S11 bar. Yes. Yeah.
yes, yes, yes.
And then ma'am, in that case, this how I calculated this S2, say for example S22 bar, because we have calculated S11 and S12.
Yes. So
Uh,
S22 will
in the
also be
previous,
1 by E2.
yeah,
E2 values
yeah,
given.
and this, yeah, yeah, and again this 10 raised to 6 by 10 raised to 9 again. How you calculated that 10 raised to 6 by 10 raised to 9?
Hmm. Because we have to find the strain in terms of micron. That's why.
So if you
So
take this,
these values will be in gigapascal. That will be the 10 to the power 9, and epsilon values will be micron. So that will be 10 to the power minus 6. So when it will go to the other side, it will become 10 to the power 6.
GPA 10 raised to 9.
Yes, gigapascal is pascal into 10 to the power 9.
Okay, okay, okay.
But
And ma'am, then
I
uh,
think you sit with your like you do some dimensional analysis and check it once. Okay.
yeah,
I never checked it for the units, but you check it once. I will also do. If still it is coming
uh,
some wrong or anything, we can discuss in next class. Okay.
then can I share my mail ID so that I will convey my actually doubts, because I am when I'm solving this assignment, there is
Yes.
one more thing is in question number 8 I'm getting some issue, like one minute. No, in question number 7, it has been asked, find the value of sigma 2 for the lamina. For already epsilon 1 is given, and we have to calculate sigma 2. So when I'm calculating this, actually my answer is getting is that for any value of sigma 2, we are getting that epsilon 1, like something I'm getting. So a little bit confused. So I would like to uh, communicate through mail ID. So
Okay. You
can I
can
share?
put your
Uh,
you share your mail ID here in the message. I will mail you with my
yes,
ID,
yes.
so you can send your like doubts and whatever answer you are getting, so that we can discuss in mail. Okay.
Yes, ma'am. I'm already sharing. Yeah, yeah,
Okay, I will mail you by
yes,
tonight or by tomorrow. I will mail. Then you can send your
sure,
problems
sure.
to me. Okay. Then
Yeah, and then one more problem, ma'am. One just question number 7.
from the assignment or the samples
Yeah,
problem?
no, samples.
Sample. Okay, 7. This one.
Yeah. Yes, yeah, same. Question number 7. So here, ma'am, I understood how we calculated S11 and S12. So there is no issue. But just could you elaborate this how we calculated S22?
Uh, there is by definition what will be S22. Okay. Uh, S22 will be epsilon 2 equal to S22 into sigma 2. Right. So epsilon sigma 2 by epsilon 2 will be E2. And E2 value is already given here, that is 10 gigapascal. So as from that S22 will be 1 by E2. So 1 by 10 gigapascal you will get the value of S22.
Or sigma 2 is not given, na, ma'am. So
Sigma 2 is 0. So,
sigma 2, because sigma 2 is 0. If we try to calculate epsilon 2, we will get S1 to sigma 1, but S22 we will get 0, if I'm not wrong.
but S2 will not be 0. Wait. Huh.
I, I think that is when we make the assumption that except sigma 2, all others are 0 that we get. That's how we can equate to 1 by E2.
No, no. Here,
What's
here only normal stress is applicable, not shear and transverse. Only longitudinal is considering.
No, we are not this was a way of showing that S11 is equal to like don't go with the value, go with the equation. So you can see E2 will be equal to S22 sigma 2. So S22 will be equal to epsilon 2 by sigma 2, and this epsilon 2 by sigma 2 is equal to 1 by E2. So it will just go with the definition. We don't need the value of epsilon 2 or sigma 2. We can just consider that that is the definition. So as it is already done here, by the definition you will get S22 equal to sigma epsilon 2 by sigma 2. Now we don't need the value of sigma 2 and epsilon 2 for that, because by the definition we know that modulus 2 will be equal to stress 2 by stress strain 2. From that we are directly equating equal to 1 by E2, and E2 value is given. That's how we get S22. Okay. So we are, as you can see here also, we are not doing anything with the sigma 1 and eta 1. We are just by the definition correlating this coefficient with the modulus. So that's how we will correlate this coefficient with the modulus 2 also for finding the S22. Okay. So the value of sigma 1 and epsilon 1 here is like we are not using the value. We are just using the correlation to justify what will be the value of S22 or S11 with respect to the engineering constants.
Now suppose we have calculated S11 based
Hmm.
on the value sigma 1 and epsilon 1 is given, right?
No, sigma 1 and no, we didn't calculate S11 with respect to sigma epsilon 1 or epsilon sigma 1. We calculated with respect to E1, that is the modulus in direction 1. We created the correlation by using the stress strain conditions and equated it with the modulus. As you can see in the question, what is given? We have given the E1 and E2, and also sir taught in the class the different the relation between these coefficients and the engineering constants. So I think initial slides also there is, yes, like this. So there is a relation between all these coefficients and the engineering constants. So from this was just an easier way to explain how you can correlate this with the engineering constants when all these values are 0. So similarly, this is the stiffness matrix, not the compliance matrix. But if
Ma'am,
you
here
see in
also S22 is not here. Q matrix is given. How to
Mhm.
calculate this Q11 and Q2 and all. But similarly, if I want to get S22, I'm not getting how to calculate that.
now that was I'm saying from the definition, you just go by the definition, right? From this table, what you can see, what will be the equation for epsilon 2?
Will be for getting that if you want to get S12 into sigma 1 and S22 into sigma 2. Likewise, and these terms are zero. So S12 sigma 1 plus S22 into sigma 2.
Hello.
Okay, do one thing. You got the value of epsilon 2, right? So epsilon 2, you know the value of epsilon 2 from here. S12 value you will get, and sigma 1 value is known. And considering sigma 2 equal to 0, S22 will be also okay. I can understand your doubt now. Even now I am also having the doubt. Sorry. Okay, I will see.
Okay, ma'am.
I will try to solve this, and okay, you gave your email ID, right?
Ma'am, already I shared my mail ID. So
Huh.
how that some matrix you have calculated, na? If you can just
Hmm.
give me that also, that will be fine also. So I will
Huh.
just
Okay,
cross
I
check
will
with that.
calculate that matrix and I
Yeah,
will send it to you.
calculate and then you can just share me that. That will be also fine, ma'am. Thank you.
Actually, I will in the next class. I will share the whole. I will do the whole calculation myself and I will share it. Okay, because
Yeah, yeah. Thank
I
you, ma'am.
got that calculated, so I didn't do it myself. So I will next class. I'm so sorry. Next class I will do that calculation and I will share it with everyone how we got that those values and if they are correct or not. And then and also I will send it to you. Okay.
Yeah, because actually that time when I was trying to solve this in the assignment problem number 7, na, I'm getting answer like for any value of sigma 2 that epsilon 1 is getting minus 17.92 micrometer per minute. So that actually I stuck into that. So I was trying to get it. So in assignment question number 7 also please go through that, ma'am. Uh,
Okay. I will go to that.
yeah, yeah.
Okay. And assignment
Thank you,
submission
ma'am.
is tomorrow, right? So I have
Yes,
to
yes, yes,
finish
yes.
it by
Yeah,
tonight. Yes, okay. I will try
yeah.
to do it by tonight and I will send.
Actually, my answer is getting it for any value of them. So actually, for that, actually, I guess uh, I'm confused at which value I should take them there for sigma 2. But my answer is getting that for any value of sigma 2, you will get that strain along one direction will be minus 17.92. So that's why a little bit confused in that.
What I will do,
Yeah,
I will try to find like do this solution. I will add that as a slide in this PPT. So and
sure, sure.
everyone can get it. Like you can go to the already the folder is shared with you. So when you I will update this PPT there,
Yes, yes.
so you can see that slide also. Everybody can see. That is the easiest and the fastest way everyone can reach out to it. Okay, so I will add that as a slide here by tonight because tomorrow night I think is a submission. So by tonight I will try to solve this so that you can change it in your assignment or anything. Okay?
Yes, thank you, ma'am.
Okay. So any other doubts? And those who have joined late, do you want me to repeat it again or you can also go to the recorded video and can see the sample problems. I will upload it by today. Yeah, video. This recording session will be uploaded by tonight in YouTube, and already the link for that YouTube is like that folder is shared with you, so you can go to that. Yeah, you can leave if you don't have it. You don't have any more doubts. As the session is till 8, so I will wait for if any new student joins or not. But if you guys have no doubts, then you can leave. Uh, okay, thank you, everyone. अभी बच्चे नहीं हो गया एक सेशन बट थोड़ा वेट करते हो गया डाउट